16 plus y equals negative 23. That one will make 8y minus this is 68 plus y equals negative 23. So both combining together gives you 9y, and then add 68 to both sides, that gives you 45. So what do we get? Y equals 5, both sides divided by 9, that gives you y equals 5. But don't forget that you have two variables here, okay, and the two unknown quantities x and y. So we just found the y value, just half done, one to go. We are going to find what x value is. You can plug this y equals 5 into 1 and 2, or even over here is okay, because this is equivalent to equation number 2. The easiest one is, yes, plug in here. Okay, so that makes x equals 2 times 5, 10 minus 17. That gives you negative 7. So the final answer, you can say negative 7 comma 5, or you can say just x equals negative 7 and the y equals 5. You can use either one. When you write this one as a coordinate, what does that mean? That means it is like you have two lines over here, 1 and 2. As you see, number 2 has a positive slope and number 1 has a negative slope, and so one is rising, one is falling. Well, these two lines intersect at one point over here. So what is the coordinate of that point? Yes, this is exactly that point. Okay, so when you take a calculus, once you are asked to find some intersection point for whatever reason, okay, intersection point meaning, just you are going to solve this equation like this. We are going to solve this same system using elimination method. Whether we use elimination method or substitution method, what we are doing over here is, well, if you have two unknown quantities in one equation, you cannot really solve that equation. So we try to make it just having just one unknown quantity. That is our goal. So 1 and 2. This time eliminate. Well, how am I going to eliminate something? Well, this is the idea. 1 here I see immediately. This is y, this is minus 2y. So if I make it 2y over here, and then 2y and minus 2y, when we add them up, it will be 0. So this is what we mean by we eliminate y value, y, okay, here. So we need 2, matching this number, so 2. So we multiply everything by 2. So this one becomes 8, and this one becomes what? Negative 46. Okay? So in other words, we multiply number 1 equation by 2. Once you do that, we can go fast. From here, yes, because once you add this 2y minus 2y cancels, add 9x equals negative 63. So x equals negative 7. Okay, x equals negative 7. So that will bring, well, number 2 equation is easier to use. So x over here, so negative 7 minus 2y equals negative 17. So negative 2y equals, add 7 to both sides, make it negative 10. So divide both sides by negative 2, that will make y equals 5. So do we get the same answer? Yes, I think so. I can see negative 7 and 5 over here. So same answer, like this. Okay. Next one, yes, let's talk about graphs. The very last lecture was about the graphs. Okay, so this is going to be a good summary. Well, there are a bunch of functions given, and we are going to determine if this function is even function or odd function, or it could be neither. Okay, neither one type, and we are going to talk about the symmetry. What kind of a symmetry does a graph have? Is it symmetric about the y-axis or x-axis or about the origin? Yes. Okay. Number 6. Y equals x. Everybody knows that. This one is a straight line, slope 1, and it passes through the origin. Okay. What do you see? Well, I'm going to talk about that. Well, this is what kind of function? Looks like an odd function because the power of x is just only one term. It has power 1, and 1 is an odd number. That one make it qualified to be an odd function. On the other hand, if you look at the graph, yes, for example, let's point here 2, 2. We go to -2 when x equals -2, y also -2. Go to exact opposite. Okay, that's why we call it is symmetric about the origin. So this one is an odd function, symmetric about the origin. Okay. Next one is y equals absolute value of x. Absolute value of x has 2 faces. One face, this positive side, is the same as y equals x. Because x is positive, then just you can remove the absolute value sign. It's going to be the same, right? 4 and the 4, the same, like this. On the other hand, when x is negative, that means negative, you apply the absolute value sign, therefore y is going to be still positive. So that's why y is still positive over here. So this V shape is the graph of this function y equals absolute value of x. Well, what kind of function is this? We can, when you have an absolute value sign, this x has a power 1. That is not relevant to talk about it at the same time because it is absolute value sign. Okay, changes the characteristic of the function. So what you have to look at over here is, graph is symmetric about the y-axis. That one make this function even. Okay, and the symmetric about the y-axis. The next one is y equals x squared. Well, unlike this one, yes, there is no absolute value sign, therefore we can talk about the power alone. Okay, it has a power 2, therefore this one make it even function. And the graph is look like this. So this is, we call it parabola. So for example, when you have a 2, y equals 4. On the other hand, if x equals -2, y value is going to be same, positive 4 over here. Okay. So this is an even function. Again, the graph is symmetric about the y-axis. Y equals square root of x. Oh, this is a different story. Okay, y equals square root of x. Do you remember the graph? This is a half of a parabola. Half of it look like this. Okay, only one side, and x is under the radical sign. Therefore, it's very, very important to recognize that the domain is just all non-negative numbers. Okay, so the graph looks like this. So the tip of the graph is at the origin. Yes, and as you see, there is no symmetry, and you cannot say this is an even function or odd function. So we call it what? Neither. and no symmetry whatsoever. Next one is, oh, did I forget y equals x cubed? Oh, I'm sorry. So I'm going to do y equals x cubed and then y equals cube root of x together here. So y equals x cubed. Increasing. When x is negative, y is negative. But when x is positive, y also positive. So look at the point, like for example here, 2, 8. Okay? And 0, 0 of course. And when x equals negative 2, negative 2 cubed is negative 8. So as you see, go to the the opposite, okay, going through this origin. So this is an odd function and the symmetry about the origin. On the other hand, y equals cube root of x. Yeah, you can call it that. It is x to the 1/3 power. Same thing. Well, the graph is, it has the same shape, but it is going to be like this. It's vertically stretched. Here is horizontally stretched over here. Okay, so for example, here when x equals 8, y equals 2. Cube root of 8 is 2. So therefore over here is negative 8. Cube root of negative 4 is negative 2. So it has a relation like this. Or whether that is vertically stretched or horizontally stretched, this is symmetric about the origin. And this same odd function and the symmetry about the origin. Okay. The very last function, unlike others, yeah, it looks more complicated. So you have y equals x squared minus 4x minus 12. What kind of function is this? Odd or even or neither? Well, look at those powers. Powers are 2 and 1, and here is x to 0, so 0. Do we see a mix? Yeah. Even powers, here is odd power. Those are mixed. Therefore, you can call this function neither. Okay? Number 7. This time we have more than one function. So it's in particular 2 functions, f and g. We are going to compose them together. So f of x is 4 over x minus 1 and g of x equals 2x squared plus x. Given this, we want to compute f circle g of 1. What do we mean by f circle g of 1? That means, by definition, okay, f of, this function g goes inside this f. So g of 1, make it like this. Okay, so this value x equals 1 is applied to g. And then g of 1 together, that is applied to f. Okay, so what is g of 1? G of 1 is plug in 1 here, so 2 plus 1 is 3. So this is the same as f of 3. F of 3, so now you have x equals 3, so just plug in here. So 4 over 3 minus 1, which is 4 over 2, which is 2. The next one is the other way around. Okay. This, now f circle g over x and g circle f of x. So first of all, Do you expect the same answer? No. Normally, you don't expect the same answer. Okay, but sometimes, yes, it can happen. Okay, so probably we may see in number 8. Okay, here. By definition, again, here by definition, this is f of g of x. So g of x is this function, so just make it f of 2x squared plus x. So what does that mean? Now the function, the final function you are going to use is f, and f is 4 over x minus 1. So whatever you go over here, this one is going to what? This one is going to replace x. Replace x. Don't be worried about this x. This is a whole quantity over here. You cannot break it. Okay? You take that one as 1 unit. So this one is going to replace x in the function. So what does that give you? That is 4 over here. 2x squared plus x minus 1. So this is gone, okay, replaced by this. So this is what you have. On the other hand, g circle f of x. That is, this time you have g of f of x. So the function f goes inside g over here, so that is g of f is 4 over x minus 1. Now look at this. What does the function g do? Once you have this input, it's going to square and then double it and then plus the input. So this time, this is the input. Yes, this is the input. This is just one unit. Okay? So goes in here, so 2 times. This one is going to be squared. So 4 over x minus 1 is squared and then added also. So once you remove this parenthesis, see what you have. X minus 1 squared, okay? Upstairs, you have a 4 squared is 16. 16 times 2 is 32. Plus 4 over x minus 1. It's good enough. You don't have to combine them together. Okay. So, as you see, once you compose, it's kind of, you are going to see the kind of both features, you see, in the final answer, 4 over something. So you see the feature of this f. At the same time, you see 2x squared plus x is in here. So you see the both features of this f and the g over here also. Number 8 again. 8 again means again this composition problem. F circle g of x and the g circle f of x. Here, what is f and g? Here, f of x is x cubed plus 4, and the g of x is cube root of x minus 4. Okay, so given this, we are going to compute. Well, again, f circle g. F is the main one, and the g of x goes inside here. So what is g of x? G of x is the cube root of x minus 4. Now, this cube root of x minus 4 will replace x in here, correct? Okay? So, this one will go in here for x, so cube root of x minus 4. And that one is going to be cubed, and then add 4. I'm sorry. Plus 4. And over here, g circle, I didn't finish this. Cube root of this cubed plus 4, so cube root cancel. So x minus 4 plus 4. is cancelled, and the final answer is x. The next one is g circle of f of x. So it's the other round. Does it make any difference? The previous example, yes, you saw the different outcome. This time, let's see. This is by definition again, this is g circle f of x, and g of f of x is x cubed plus 4. So now x cubed plus 4 go in here for x. Is that right? Therefore, what do you see? We have inside of cube root, and you have x cubed plus 4. Go in here and then subtract 4. Okay? So plus 4 minus 4 cancels. Therefore, what's left? Cube root of x cubed. What is that? Isn't this x? Yes. So this time, we calculated this composition of these two functions f and g, and we swap the order, and we get the same final answer of x and x. Yes. Sometimes it happens. Yes, we are going to see this one in a couple of weeks again. Okay? Sometimes it happens. When it happens, we call it the function f and g are inverse of each other. Okay, inverse functions. Yes, only in that case the composition will be the same, and the result is going to be x. Okay. Number 9. Number 9. You have decide if each relation defines a function, and give the domain and the range also. By the way, whether this relation is a function or not, well, we still can talk about domain and the range no matter what. Okay? So A is 2, 1, 7, 3, 0, 3, and 7, 0. When you have this, yeah, this is a relation. Relation means just x value and y value together. That is a relation. Among those, what is a function? The function means just for each x value, there is exactly one y value over here. So let's see over here. 2 goes to 1, 7 goes to 3, and then over here I see 7 goes to 1. So that means same x value 7 has 2 corresponding y values. So that one violates the rule of a function. So this is not a function. So visually, what is important, if there is a repeats in x value, then that's not a function. Okay? Repeats in the x values. Y values doesn't matter. Okay. And still we can talk about domain and range.